Right now, your head is aging faster than your feet. That is not a figure of speech. And it is not something two physicists argued about on paper. It has been measured, and the number is not in dispute. Gravity does not only pull you down, it slows you. The deeper you sit in it, the slower everything about you runs. And your feet sit deeper than your head does. Every hour you spend standing up, the two ends of you drift further apart. In 2022, a laboratory in Colorado pushed that measurement down to a millimeter. One sample of atoms, about as thick as the card in your wallet. They read the top of it and the bottom of it as two separate clocks. The top ran faster. Same room, same table, same air, a millimeter apart. Nobody has ever found the distance where the effect stops. They keep building better instruments, and every time, it is already there waiting. Which means the number you have been calling your age is not one number. It is a spread, not a number. And people have been measuring that spread for a lot longer than you would guess. In 1959, two physicists at Harvard, Robert Pound and Glenn Rebka, ran what was probably the first clean test of it. They did not use a clock at all. So how do you measure time without one? They dropped a beam of light down a lift shaft, 22 meters of it, and measured what the fall had done on the way. The light came out changed, about 1 part in 1,000 million, which is a number you cannot picture and they could still read. 22 meters of an ordinary university building was apparently enough to do it. Then, in 1976, NASA bolted a clock to a rocket and threw it 10,000 kilometers straight up into the sky. A physicist named Robert Vessot ran that one, and the setup seems absurd until you see the numbers. The clock on the rocket ran faster than the one left on the ground, by exactly the predicted amount. That result is still standing as one of the most precisely confirmed things in all of physics. Nobody in the field argues about any of this, so what does any of that actually cost you? Here is the bill, and it is larger than the experiments. If every place runs at its own rate, then the word now apparently stops working across distance. So how far does it hold? About as far as you can reach. Not slowly. Completely. There is likely no fact about what is happening on the other side of the galaxy while you sit in your chair. Not a hidden fact. No fact. Because there is no shared line to draw between here and there. You look up at night and you think you are watching the sky. You are watching a stack of separate pasts. Each one arrives from a place that runs on its own schedule, and none of them line up. A star you have a name for may have been dead 4,000 years, and the light is still arriving on schedule. And something moving toward us has no now that we can share with it. Not a delayed now, not a now we have to wait for. None at all. Every early warning system anybody has ever sketched out assumes one thing: that there is a moment out there to be seen, and that we are looking at it. That assumption is the part nobody has ever solved, and most people have never noticed it is there. So if there is no moment out there for you to see, what is there instead? A signal. That is the entire list, and it is a very short one. Everything you know about anything past your own skin arrived as something traveling. Light, radio, sound crossing a room to your ear. All of them take time, and none of them can be hurried. Einstein worked that out in 1905, and he did it without an instrument. He started from something already sitting in the textbooks. Every measurement anybody had taken said the same thing. Light moves at one speed no matter how fast you chase it. Run after a train and the train slows down relative to you. Run after a beam of light and it does not. Instead of calling that an error, he took it as the rule and asked what else would have to be true. If the speed never changes, then the things that measure it likely have to. Lengths shorten, clocks slow, and nothing carrying information can go faster than that beam. Later they apparently checked it with particle accelerators, then with clocks flown on aircraft, then with satellites. It is held every time, which means the world itself never reaches you. Only reports of it do, and they arrive stale. Now look at the sun. What you were seeing left it 8 minutes ago, and 8 minutes is a long while in the life of a star. If it went out while you sat there, you would carry on with your afternoon. The light would keep arriving on schedule. Nothing in your experience would tell you. And you would not find out about it for 8 minutes. The moon puts you a second and a half behind. The man across the table from you drops it to billionths, which is nothing at all. And it is still not zero. It has likely never once been zero for anybody. So where does that leave you? Inside a few meters of space where the news is very nearly current. Everybody you have ever loved sits in that bubble with you, and it is the only place where anything is almost now. Past that, everything gets older the further out you look, and it seemingly keeps getting older with no end to it. So are you looking at the universe out there? You are not, and you never have been. You are reading its post, sorted by distance. The further the sender, the longer the letter has been in transit, which seems to leave one thing to say about all of it. You have never touched the world. You have only ever read the mail it sent you. Reading the mail is one thing, and you can live with that. Sorting it into order is where your trouble starts. And one night in 1987 shows you exactly why. On the 23rd of February, 3 detectors buried deep underground registered a burst of particles within seconds of each other. One in Japan, one in Ohio, one in the Caucasus. Nobody on shift knew what they were looking at. Did anybody work it out that night? Not for days. 3 hours later, telescopes in the southern hemisphere caught the light from a star collapsing in the galaxy next door to yours. Same object, same collapse. 2 arrivals, 3 hours apart, and both of them real. So which of those 2 arrivals was the event itself? Neither one of them was. Both were reports sent by different carriers that apparently do not travel together. And that was the case where everything worked in our favor. 3 hours of warning, and nothing headed our way. Now take a gamma ray burst instead. It starts as a collapse of the same kind, but the energy leaves as a narrow beam of hard radiation instead of spreading out in every direction, and that changes everything about it. So what happens if one of those beams crosses this planet? It likely strips a large fraction of the ozone layer in a matter of seconds. The ultraviolet that comes through afterwards kills the plankton at the base of the ocean food chain. Everything standing on that chain probably follows it down. You are standing on that chain as well, near the top of it. Some researchers think that is likely what ended the Ordovician 440 million years ago. Most life on your planet was gone by the time it finished, and it took millions of years to come back. And here is the part that should hold your attention, because it is not about the beam. That beam travels at the speed of light. So the beam and the news of the beam arrive at your position in the same instant. Nothing seems to run ahead of it because nothing in this universe is able to. Astronomers have catalogued thousands of these things by now. Every single one of them was recorded after it had already finished happening somewhere else. Not one of them has ever been seen approaching. Nobody in the field expects that to change. So nothing can be seen coming. Fine. At least what you can already see is yours to keep, right? It is not. There are roughly 2 trillion galaxies in the part of the universe you can see from here. Around 97% of them are already out of reach. Not far, not difficult, out of reach, permanently. Launch a ship at one of them today, moving at the speed of light, and you never arrive. The reason is that space between galaxies is stretching, and the further off something sits, the faster it pulls away. Far enough out that retreat beats light itself. A galaxy past that line goes on shining, and its light simply stops reaching you. Not late, never again. And galaxies keep crossing that line, one after another, while nobody is watching for it. In 2007, 2 physicists sat down and worked out what all that means. Lawrence Krauss and Robert Scherer. Their question was simple. What will anybody looking up in the far future actually see? Their answer is a good deal worse than just a smaller sky. Given enough time, everything outside your own galaxy will likely have crossed that line. An astronomer then points better instruments than ours at the sky, He sees one island of stars sitting in an empty void. No other galaxies anywhere. No leftover glow from the beginning. Nothing at all to measure a retreat against. And here is the part that should stay with you, because it is not about him. That astronomer would not be missing anything. Not a single piece of data. He would be looking at the complete record available from where he stands. And that record would tell him the universe is static, eternal and small. He would be careful about it. He would check his work. He would be wrong about all of it. And there would be no way left for him to ever find that out. Which puts a question in front of you that has no good answer. How would we know if it had already happened to us? If something crossed that line before anybody here was looking, it apparently left no trace, and no gap where a trace ought to be. The record we hold looks complete. It would probably look exactly this complete either way. Every number in cosmology, every age and every distance, likely comes out of the light that still reaches us. And nobody has any idea how much of it has already stopped arriving. Here is what that cost you, and it is not a philosophical loss. In 2021, a researcher at Oxford named Toby Ord ran the arithmetic on a straightforward question. How much of the universe could your species ever actually reach? He was generous with the assumptions too. Say we get very good at this. Say we leave tomorrow morning, traveling at the speed of light the whole way. The answer comes out at around 4% of what you can currently see in the sky. Everything else is already gone, written off, and that 4% is not a fixed number. It is falling. Space keeps stretching. The boundary keeps pulling inward. Objects keep sliding across it in the wrong direction, and none of them come back. Every hour that passes, more of the universe drops off the list of places anything from here could ever go, including you, and everything that comes after you. And nobody has to do anything for that to keep happening. There is no decision to make. No policy to change, no technology that helps, because the limit is not an engineering problem. It is the speed of light, set against the expansion of space itself. And the expansion is winning, comfortably. So, what does that do to the search everybody talks about? It changes the question entirely. If there is another civilization out there, then across most of that sky, we cannot reach them and they cannot reach us. Not with better rockets, not with anything. Is that a limit somebody could argue with? It is not. A signal sent from either side spends the rest of eternity chasing a target that keeps pulling away from it. So the silence people keep asking about may not be a mystery at all. It may simply be what a room sounds like when everybody was sealed into a separate box, long before anybody learned to speak. And those boxes are still sealing tonight. Not one person on this planet can hear it happening. Which is the part that should sit badly with you. Whatever is out there, most of it stopped being available before your species had language. Not because anybody closed a door, because the geometry never allowed it open in the first place, and nobody noticed until somebody did the sum in 2021. Every plan anybody has drawn for going out there was drawn on the assumption that the map stays the size it is. It does not. The map has been shrinking since before there was anybody here to read it. Twice now, the answer has come back at you as nobody knows, and both times the question was when. So ask it properly, about one specific thing, with instruments. On the 14th of September 2015, at 51 minutes past 9 in the morning, a machine in Louisiana twitched. Nobody was watching the screens. It had been switched on 4 days earlier. 7,000ths of a second later, an identical machine in Washington state did the same thing. 3,000 kilometers apart, and neither one is connected to the other. Both machines are called LIGO. Both are 4-kilometer tunnels with a laser running the length of them, built to catch something nobody had ever caught before. The whole signal lasted a fifth of a second. You could not have blinked in time to miss it. So what made it? 2 black holes falling into each other. One about 36 times the mass of the sun, the other about 29. In the final moments, they were circling each other at half the speed of light. 3 suns worth of mass disappeared and came out the other side as a shudder in the shape of space itself. Now here is the part that should stop you. That merger happened 1.3 billion years ago. When that wave set out, there was nothing on your planet but single cells sitting in water. Everything that ever lived on land arrived, spread out and died, while that signal was still in transit. So when did it actually happen? Ask a physicist and he will probably say 2015, because that is when it arrived, and that is the only date anybody can honestly put on it. Ask what was happening out there while your grandfather was alive, and there is no answer at all. There is no line running from his kitchen to that place. So does that event have a date? It has one here. It does not appear to have one out there, and nothing anybody builds is going to give it one. And this is where it turns on you. That merger sat in your future for 1 billion years, then in your past, and nothing about it changed in between. What changed was where the wave had got to, which means the words already happened describe the wave, not the event. Every catastrophe out there sits somewhere on that same list. Each one waits to be moved from future to past by nothing more than a signal finishing its journey. Some of them are likely already past for anybody standing closer in. Nobody here has any way to know which. None of that would matter if the effect only showed up across 1 billion light years. It shows up on a hill you could walk up in an afternoon. In 1941, 2 physicists hauled a detector up Mount Washington in New Hampshire. You can drive to the top of it today. Bruno Rossi and David Hall wanted to count muons, and the mountain was the cheapest laboratory available. A muon is a particle that gets made when cosmic rays slam into the top of the atmosphere, and it does not last long. Left alone, it survives roughly 2 millionths of a second before it comes apart. At the summit, 6,000 feet up, they counted how many came down through the detector. Then they hauled the detector back down to sea level and counted all over again. Now, here is the arithmetic anybody can do on paper. Even moving at nearly the speed of light, a muon should only cover about 600 meters in its whole lifetime. The mountain is nearly 2,000 meters tall. So how many of them should have reached the bottom? Almost none at all. Most of them did anyway. So were those particles living longer? Not by their own reckoning, no. They lasted exactly as long as they always last. What changed was how much of that mountain went past them while they did it. From the mountain's side, those particles apparently aged slowly. From the particle's side, the mountain was simply shorter than it looks to you. Both descriptions give the same count at the bottom of the hill. And there is likely no third description anywhere that settles which of the two is really happening. Which brings all of it straight back to the chair you were sitting in. That particle crossed a mountain that should have been far too tall for it, because it was moving fast enough for the difference to show. You are not. Nobody you know is. Every human being who has ever lived has crawled around on one rock, at one speed, within a few thousand kilometers of everybody else. So why does your calendar match your neighbor's? That is the only reason. Nothing deeper than that. It is probably not a law of anything. Just an accident of everybody standing in one spot. And the moment somebody stops standing there, the arrangement stops holding. A crew moving fast enough for the effect to show would come back to find their own children older than they are. Not as a paradox, as paperwork, filed by a registrar who has no column for it. Take that further, because there is a version of it somebody has already measured on people. Not on paper, on people you could name. Since the year 2000, there has been somebody living continuously off your planet. Up on the space station, moving at around 28,000 kilometers an hour, day and night. Gennady Padalka spent more days up there than any human being in history. 878 of them, across 5 missions. When he came home, he was roughly 1/100th of a second younger than he would have been had he stayed on the ground. So is 1/100th of a second worth anybody's attention? It is. And here is why. He came back to a planet where slightly more had happened than had happened to him personally. That difference is permanent. Nobody can give it back to him. What would you even give back? There is nothing to hand over. Now scale that up honestly, and keep the arithmetic the same. Send a crew out at a decent fraction of light speed. Let them run a few years by their own clocks, then bring them home. They step off onto a world where decades have gone by without them. Their families are old, or they're not there anymore. The program that sent them was probably shut down a generation ago. And they are not late. Late would mean there was a schedule they missed. There was no schedule because there is apparently no shared clock for anybody to be late against. They simply lived a shorter life than the planet did. So, which of those two amounts is the real one? Both are correct, and neither is the real one, because there is no real one on offer. And that is the mild case. It was run on a man who never went further than 400 kilometers above your head. Everything about your life sits on the assumption that a year is a year for everybody. Contracts, ages, the order of who was born first, the sentence a court hands down, and the promise to be home by Christmas. None of that survives distance and speed. It works for you because nobody here has ever actually gone anywhere. The moment somebody does, in any serious way, your species has two calendars running at once. No procedure exists anywhere for reconciling those two, and no authority on this planet could rule on which one counts. Put all of it in one place, and look at what you are left holding. No moment is shared across any real distance. Nothing anywhere marks off what exists right now. The order of two distant events depends on who is doing the asking. Two people moving differently disagree about how much has happened, and both of them turn out to be correct. And the agreement everybody on this planet enjoys is likely an accident. We have all been standing in the same spot, at the same speed, since the beginning. So what exactly is the thing everybody has been calling time? Physicists have had a name for what is actually there since 1908, when Minkowski laid the whole structure out in Cologne. They call it proper time, and hardly anybody outside the field has heard of it. That is not a poetic phrase. It is a bookkeeping one, and it means what it says. Proper time is the amount accumulated along one specific path through the world, and only that path. Nothing more than that, and nothing less. It is not measured against a background, because there is no background to measure it against. It is simply the total that one thing racks up by going where it went, at the speed it went, through whatever gravity it passed on the way. Every object out there carries its own, and every one of them carries a different total. Yours differs from the one belonging to the man beside you. Both of yours differ from a satellite passing overhead. So who is adding all of those separate totals up? Nobody is. There is apparently nothing to add them into, which turns the ordinary way of putting it inside out. Does anything actually travel through time? Nothing does. You do not move through time either. Time is the count your own path produces. It exists because you took that path, and probably for no other reason at all, which leaves one place still standing. Everything said so far has been about distance, about things far enough away that the disagreement grows large enough for somebody to notice it. Nothing in any of it touches the space inside your own skin. You are one object, sitting in one chair. Whatever the galaxies are up to, there is at least a now in there that belongs to you and to nobody else. That is the last piece of ground anybody has left, and it went first. It went in 1850, and almost nobody outside the laboratories noticed it going. You have never questioned it either. In 1850, a German physicist named Hermann von Helmholtz went and tested that. He started out on a frog leg, then moved on to people, which was likely not a popular procedure at the time. He wanted to know how fast a nerve carries a signal from one end of a body to the other. Everybody expected that answer to come back instant, or very near it. Thought feels instant from the inside. So why on earth would it not be? He measured roughly 27 meters a second, and no faster. That is all it was. Slower than a car on a residential street. So why did that cause an argument? It is easy enough to see. The signal from your foot arrives later than the signal from your face, every time, without exception. And no department inside you has the job of sitting there waiting for the stragglers. So sit still for a second and count what that actually cost you. Touch your knee and touch your cheek at the very same instant. The two reports land in your head milliseconds apart every time. Your body is probably not one object having one experience. It is a crowd of separate reports arriving out of order from different distances inside you, and something in there is assembling them into one smooth afternoon that never happened anywhere. So that was the last place you had left, and it is gone as well. There is no moment out in the universe, and there is no moment inside you either, which means the thing you have been calling now was built, and something is doing the building. And that opens a door nobody wants opened. If your now is assembled, then it can be assembled wrong. It can be assembled late. It can be assembled out of order and handed to you looking perfectly clean, and you would have no way of checking it. The only instrument you own for checking is the same one doing the assembly. Everything you have ever been certain about happened inside that report. Every decision. Everything you swear you saw. So how much of it arrived in the order you remember? Nobody knows. People who study this for a living have been pulling it apart for the last 30 years. What they have found is a good deal worse than a delay. In 1972, two researchers at Princeton stumbled onto it, and it happens on your own arm. You could set the whole thing up at home with 2 fingers and a bit of patience. Frank Geldard and Carl Sherrick were working on touch, which sounds like the dullest corner of the field until you see what came out of it. They strapped a small tapper to a person's wrist and delivered 5 quick taps. Then a second tapper up near the elbow delivered 5 more of them. Nothing at all touched the forearm in between the two. So what does the person in the chair report? Not 2 clusters. They describe something hopping evenly up the arm, tap by tap, straight across skin that nothing came anywhere near. Geldard called it the rabbit, and the name has stuck ever since. Now work out when your brain could possibly have known. The taps at the wrist land first, one after another. At that instant, nothing has happened at the elbow yet. Nothing in the room says anything is going to happen there either. So how do you space those first taps out along the arm without knowing where the series ends? You cannot. Nothing can. And yet the sensation arrives already spaced out, evenly, as though somebody had planned the route in advance. So what does that leave? The report was not assembled as it happened. It was held back, waited on, and written up only once the ending had come in. Your skin never felt a single thing on that forearm. Something decided afterwards that it had, and filed the memory under a moment that was already gone. Nobody signed off on that decision. Nobody was asked about it. And the same machinery is running right now on everything reaching you. The report you are reading was written after the events in it by something that had time to edit. Sit with the size of that gap for a second. The gap between what happened to you and what you were told happened is short. A few tens of milliseconds at most, on a good day. But it is not 0, and inside it there is a room for editing. Everything you are certain about arrived through that gap. Every face you recognized, every word you heard, in the order you believe you heard it. None of it came to you raw. It came through a process that had already seen the ending before it handed you the beginning. So if the thing is being written, how often does the pen come down on the page? There is a number for that, and it is not a comfortable one to hear. Your present apparently does not run continuously at all. It comes in slices. Current estimates put the rate somewhere between 8 and 13 slices a second. It is tied to a rhythm that a German named Hans Berger first pulled off a human scalp in 1929. He worked in secret for years over it because his colleagues were convinced he had lost his mind. Between those slices, there is no now for you. Not a faint one. None at all. The interval is simply not represented anywhere inside you, and nothing anywhere marks its absence. So the smooth, continuous present you live in is likely built out of samples, the way a film is built out of frames, and the smoothness is the part that gets added afterwards. There is a way to catch the machinery at it. Stand in front of the mirror in your bathroom, close enough to see your own eyes properly, and look from one eye to the other. Back and forth, as many times as you care to try it. you will never once catch your own eyes moving. Somebody standing beside you sees them move every single time, plainly, with no trick involved. So where does the movement go? It gets cut out while it happens. The two ends are stitched together, and the join carries a timestamp that covers the whole stretch. So add that up across one ordinary day. You end up with close to an hour that has no time attached to it at all. That is not lost time. It is time that was never issued to you in the first place. Now ask what that does to a whole lifetime of them. Take 80 years and subtract an hour from every day of it. You're looking at something close to 3 years that never carried a timestamp at all. Nobody is out looking for those 3 years. They are not stored anywhere in you, and there is no gap sitting where they ought to be. Your own record shows a full 80 years, unbroken, with nothing at all marked absent. So which of those two numbers is your actual life? The one the planet counted off outside, or the one you were actually issued in here? Both are real. The two do not match, and the shorter one is the only one you have ever actually lived through. Missing time is one thing. Time that gets moved is another, and there is an old laboratory trick that catches it happening in front of you. Two lamps sitting on a bench, side by side, about a hand's width apart. Flash the left one. Then flash the right one about 60 milliseconds later. So what does anybody in the room see? Not two separate lamps. Everybody in the room sees one single light, sliding across the gap between them. Max Wertheimer published that result in 1912, and an entire school of psychology grew out of it afterwards. Now change exactly one thing about the setup. Make the left lamp red and the right lamp green, and run it again. What people report is a single light that travels across the gap and changes color halfway. Not at the far end where the green lamp is, halfway across. And there is the problem, sitting in plain view. At the moment that light is halfway across, the green lamp has not fired yet. Nothing in that room knows the second color is going to be green. Nothing in there could possibly know it yet. There is likely no red left in the world at that point either. Both flashes are over and done before any of it reaches the person watching. So, who picked that halfway point? Something did, apparently after seeing both flashes, and then wrote the change back into a moment that had already gone by. So you are not watching events arrive in the order they happened. You are being handed an order that was worked out afterwards. The process doing the work had both ends of it on the table, before it decided where the middle went. And none of that is a fault in the wiring. It is the wiring working properly. Every sequence you are sure about has been through the same shop. The order of two words in an argument with somebody you love. Which of two cars moved first at a junction? Whether the bang came before the flash or after it. In each of those, your machinery probably had both ends before it settled the middle. Then it handed you the finished version with the timestamps already written in. So how would you tell a real order from an assigned one? By checking it against something outside yourself. A recording, a second person, an instrument. Every one of those has to be read by the same kind of machinery, running the same procedure in another head. Moving a moment around inside one head is bad enough on its own. Two heads in the same room is where it stops being a curiosity and starts costing you something. In 2026, a group publishing in the journal Psychological Research ran a very simple setup. Show somebody two events, one nearer, one further off. Then ask which of the two happened first. Both were fired at the very same instant. People said the far one happened earlier. They said it consistently. Not that it looked earlier to them or seemed earlier. It happened earlier. And the further away it sat, the earlier they put it. So is that just the light taking longer to get there? It is not. At those distances, the light arrives together for any practical purpose. The judgment is apparently being made after the signals land, and distance is one of the things feeding into it. So put two people in that room, sitting at different distances from the same pair of events. Put yourself in one of the chairs. Both of you watch it happen. Both of you are honest about what you saw. You walk out with different orders. Each of you is reporting exactly what your own machinery issued you, and neither of you is wrong. So which of the two accounts does the record follow? There is likely no third account anywhere to check either of you against. Two people in the same room do not agree on what happened first, and both of them are telling the truth, which leaves the word first without much of a job to do. What is it even describing? It is probably not something the events themselves carry. It is something a body works out for itself, using where it happens to be standing at the time. Now widen it. Two aircraft crews report the same sequence of events differently. Two drivers at a junction each swear the other went first. Two people watching the same man fall in the same room put it in opposite orders. Both pass every check anybody can run on them. This is not memory going soft later on. The disagreement is likely manufactured at the moment of perceiving, by bodies sitting in slightly different places. It is already in the report before anybody has had time to forget a thing. Every legal system on this planet rests on one assumption: that a careful, honest person can say what happened first. Instruments, then. Put a camera on the thing and the argument goes away, you would think. It is the obvious move, and it is worth following all the way down, because it does not end where you would expect. A high-speed camera apparently does not record time at all. It records frames, and somebody chose the rate. Run one at 1,000 frames a second, and two events 40 microseconds apart land inside the same frame. In that recording, they happen together. Nothing in the file says otherwise, and no amount of looking harder brings the order back. So buy faster equipment. The same problem just moves down a level. The fastest pulsers anybody has built work in attoseconds, and the people who managed it took a Nobel Prize for it in 2023. Below their window, the order has gone the same way. So is there a level where the order becomes solid? There is always a floor, and that floor is likely set by whoever bought the equipment. Now run the chain out to the end. The camera hands its frames over to software. The software stamps them with a time taken from a clock. That clock sits on a circuit board somewhere, running at its own rate, at its own height above sea level, drifting quietly against every other clock in the building. And somebody wrote the code that decides what counts as the same instant. A person, at a desk, making a call. Then, at the end of all of it, a person reads the output, with the same tissue, running the same assembly you have been hearing about. So where in that chain does the order become a fact about the world? Nowhere you can point to. The chain never leaves the machinery. It probably just gets longer, which is worth stopping on because it likely applies to everything your species has ever established. Every experiment in every field ran on instruments with a flaw, read by people with a flaw of their own. Every date in every history book on your shelf came out of a chain like that one. The whole record is a stack of readings, each taken by something that had to decide where one moment ended and the next began. So does that make any of it wrong? It does not. It makes all of it a report, and there has never been anything else on offer. Nobody has ever checked the world directly. In all this time, there is no procedure for it, and there is no instrument that would do it. Here is where somebody stopped arguing about it and built the thing instead. You can go and look at it. In 2018, a team in Vienna set up an experiment with two operations and a single particle of light. Kaslav Bruckner had worked out the theory behind it. Call the operations A and B. In any laboratory ever built before that, you do A and then B, or B and then A. The paperwork records which one, and nobody thinks about it twice. They built an arrangement where the particle goes through both, and no fact exists anywhere about which came first. Not unknown to them. Not too fast to catch. There is apparently no ordering in the system at all, for anybody to find. So how would you ever check a claim like that? That part is the whole point. Say the two operations did happen in some definite order, and the equipment was simply hiding it. Then the results are boxed in by a limit anybody can calculate on paper. Run the experiment, tally the outcomes, and your number has to land under that limit. It came in over that limit, well over. The measured value sat several standard deviations past the point where any hidden order remains possible. That result has now been repeated in Vienna, in Hefei, in Queensland. Different hardware, different teams, most of them trying to knock it down. It holds every time. There are states of matter where A happened before B and B happened before A, and both are the answer. Not as a way of speaking, as a number on a screen in a building you could drive to. So what does that cost outside the laboratory? Start with the thing everybody leans on every day without noticing. Cause and effect. Which one is that exactly? You know the wiring in your house is safe because the fuse blows before the fire gets going. You know a drug works because the recovery follows the dose and not the other way around. Every one of those judgments probably rests on knowing which came first. And physics has now produced a system where that question has no answer at all. It is a small system, built on a bench, and nobody is claiming your kitchen behaves like that. But it exists, and it works. And it apparently means the order you rely on is not a rule of the universe. It is likely a local condition that usually holds. Usually holds is a strange thing to say about the rules of a universe you live in. So where does that boundary actually sit? In 2019, Magdalena Zich, Fabio Costa and Bruckner published an answer to that. And the shape of it is not what anybody wanted. Put a clock somewhere, gravity is strong and it runs slow. You heard that part earlier, and it has not changed since. It has been on the books for a century now, unchallenged. Now put the lump of mass making that gravity into two positions at once. Quantum mechanics permits that. And it has been done with objects big enough to hold in your hand. The clock sitting beside that lump of mass now has two rates at once. So how much time has actually gone by next to it? Two different amounts, both at the same time. And two different amounts means the events near that clock have no fixed order against anything else in the room. So the order of events out there depends on where a lump of matter happens to be sitting. And a lump of matter does not have to be sitting in any one particular place at all. That is the whole mechanism. Not a trick of the apparatus, and probably not an interpretation anybody chose to put on it. Gravity and quantum mechanics, both confirmed to an absurd number of decimal places, and put together the only way anybody can put them together. And the sequence of events falls straight out the bottom of the arrangement. Nobody built that arrangement to be provocative about it. It is what you get when you write down the two best theories anybody has, and then refuse to look away from the page. So how far does that reach? Every mass lightly bends time around itself. Yours is doing it right now. The chair you are sitting in does it too. The planet under the floor does it hard enough to split your head from your feet. That is where this whole account started. And every one of those masses is built from parts that quantum mechanics allows to sit in more than one place at a time. The effect is unmeasurably small at your size. It is probably not zero either, and there is no line anywhere marking where it switches off. Nobody has ever found that line. Most people working on this apparently expect there is no line there to find. Nothing in either theory puts one there. Put the two halves of this next to each other and look at what you are holding. On one side, your own body. It assembles a moment out of late signals and issues it with a timestamp. It picked itself. On the other side, matter that refuses to commit to an order when the mass around it has not settled anywhere. Two completely separate fields, working on unrelated problems, arriving at exactly the same refusal. Neither one of them will hand over a now. And notice that their reasons do not overlap anywhere. Not at a single point. The body does it because signals take time to arrive, and something in there has to reconcile them before you see anything. The physics does it because gravity depends on where mass sits, and mass does not always sit anywhere in particular. So are those two versions of the same idea? They are not. They are two independent failures of one assumption. The assumption is that there is a moment out there, waiting to be found by somebody careful enough. So what happens if you take that seriously? Every model anybody has ever built starts the same way. A weather forecast, a court transcript, an engineering simulation of a bridge. You write down the state of things at a given instant, then you run it forward. That first step is likely the one nobody checks. There may be no state of things at a given instant to write down, not hidden. Not too fine to measure. Simply not a thing this universe keeps on file. There is a name for the trouble all this causes, and it has been sitting in the equation since 1967. Every physical theory apparently needs two things: a starting state and a rule for moving it along. Take the rule away and you are left with a photograph of nothing in particular. Take the starting state away and the rule has nothing at all to act on. Both halves have now taken damage from a different direction, and neither field is in a position to repair the other. So what holds your day together, if not a sequence of moments? Something probably does. You woke up this morning, things happened to you, and they happened in an order you could recite on demand. That order is real enough to build a whole life on. The question is what that order is made of, because it is apparently not made of time. Answer that one with something you can put your hand on. Your day is likely held together by traces. Coffee that cooled in the cup while you were talking. Dishes that moved from the table to the rack. A message you sent sitting above another one you sent afterwards. Every one of those is a record left in matter, and every one of them reads one way round only. So has anybody ever walked into a kitchen and found the coffee warmer than they left it? Not once, not anywhere on this planet. So that is apparently where your order comes from, not from a clock overhead handing out moments. From the fact that some arrangements leave marks, and the marks pile up. In 1929, Leo Szilard made the connection that turns all of that into physics, rather than housekeeping. He was working through an old puzzle about a creature sorting molecules at a doorway. What he showed is that information about a system can be turned into work. So a record is probably not bookkeeping at all. It is a physical thing, with an energy cost attached, sitting in matter. So the sequence you can recite is real enough. It is just apparently not made out of time. It is made of records, laid down in physical stuff, and each one of them was paid for out of something real. And that raises the question this whole account has been building toward, though nobody usually says it out loud. If your order comes out of records, and records cost energy to make, then who exactly has been paying for yours? Now look at what your own body has been doing this whole time you sat there listening. Every cell in it has been laying down records without pause. Which molecule bound to which one? What the temperature was in that moment? What arrived at the surface and what went back out? None of that is a side effect of being alive. It is most of what being alive consists of. So what is a memory actually made of, physically speaking? The same thing as all the rest of it. A structural change, held in tissue, that was not there yesterday and is there today. Your entire past exists as marks in matter. Every one of those marks had to be written by something, and the writing had to be paid for. That bill has been running since before you could talk, and nobody has ever shown it to you. You are. Nobody else has ever picked up any part of that bill. There is a figure for it. Seymour Keaty and Carl Schmitt worked it out in 1948. The two of them set out to measure how much energy the human brain draws just to keep itself running. The organ makes up about 2% of your body weight, and no more than that. It takes roughly 20% of everything you burn in a day. In ordinary units, that comes to around 20 joules every second. Awake or asleep, from the day you were born until the day it stops. 20 watts is roughly the bulb in a refrigerator door. A small, steady draw, nothing anybody would ever notice on a bill at the end of the month. So what does that 20 watts actually buy you? Not your thoughts, for most of the time. And probably not decisions either, since most of what goes on down there never reaches you at all. What it buys is the writing itself. Laying down which molecule bound to which. Holding the record steady against everything trying to smear it. Keeping the whole sequence in an order that can be read back later. That is where the 20 watts goes. So what does that make you? It turns the whole ordinary picture inside out. You are not a person moving through time and collecting experiences as they arrive. You are a system that pays continuously to write records. And the sequence you call your life is what those records look like. Read back in the order they were laid down. Stop paying, and the writing stops that same day. There is no version of this where the record carries on without the tissue underneath it. Now put a number on what all that comes to over a life. 20 joules a second, run across 80 years, comes out at roughly 50 billion joules. That is enough to run a small town for an afternoon, and all of it went on keeping one record in order. And that record is likely the only place any of it survives. So where exactly is your own childhood being kept? It is not out there in the world anywhere. The rooms have been repainted. The people have moved away or died. The light that left those afternoons is somewhere past Neptune by now, still going out. What is left is written in tissue that you are paying to maintain. The payment has never once been interrupted. One thing about your record has been sitting there this whole time, unexamined. It only ever gets longer. Marks go into it, and no marks ever come back out. You accumulate, and you never unaccumulate. And every process you have ever watched works the same way. The cup on your desk cools, the tire wears down, the paint fades on the side of a house. Has anybody anywhere ever seen one of those run the other way? Not once in the entire history of people looking. So the obvious thing to say is that this is simply what time does. Time moves forward, and forward is simply the direction the wearing goes in. So where is that written down? Go and look for it in the rules. Write out the equation for two balls colliding on a pool table, then film the collision. Then play that film backwards and watch it again. The reversed footage obeys that same equation exactly, with nothing violated anywhere in it. The same apparently holds for the equations of electricity, of gravity, of quantum mechanics, written down in 1926, and standing unchanged ever since. Every fundamental law anybody has ever written down works identically in both directions, and there is likely no arrow in a single one of them. So, what does that leave? A hole that ought to be keeping somebody awake at night. The forward direction of your entire life is not written anywhere in the laws that run this universe, not in a single one of them. The one thing about time that never wavers, the reason the cup cools, and your face changes in the mirror, and the dead stay dead. People noticed that hole a long time ago, and the arguing about it has apparently never stopped. Some of that argument is very old indeed. Ludwig Boltzmann was asked in the 1870s how a set of reversible rules produces a world that only runs one way. The answer he gave probably cost him the rest of his career. Some of it is from this decade. It involves changing that direction inside a small system by choosing how you look at it. What nobody has produced after 150 years of work is a law that says forward. The direction everybody on this planet builds a life on is apparently not a rule of anything. It is likely a leftover from something else, and the whole argument is about what. So start that argument where it actually starts, because the first step in it is worse than it sounds. If the laws work equally well in both directions, then every process you have ever watched apparently has a legal reverse. Not a loophole somewhere in the wording, not an exception somebody has been hiding. The reverse is permitted by the same equations that permit the forward version. It stands on exactly the same footing as the version you know. Take the cup sitting on your desk right now. What is that cup actually allowed to do? Heat leaving it and spreading out into the room is allowed, obviously, and heat gathering back out of the room and returning into the cup is apparently just as allowed. Both directions satisfy every law anybody has ever written down. So does a plate on your kitchen floor gathering itself back into one piece and lifting onto the table. So does smoke drawing back down into a chimney and gathering itself into coal. So does a scar on your arm opening back into a cut, with the blood running upward into it. So how many of those has anybody actually seen happen? Every one of them is legal. Not one of them has probably ever been observed. Not by anybody. Not anywhere. Not in the entire history of people watching things happen. That is the size of the gap you have been standing over your whole life. On one side, a set of rules that permits both directions with no preference between them. On the other, a world that has apparently run one way every second since it started, with no recorded exception anywhere in it. So something stands between those two things. holding one direction shut. It is likely not a law, because there is no law there to do the standing. Arthur Eddington gave that gap a name in 1927, and the name has stuck to it ever since. He called it the arrow of time, and he was very careful about how he put it. He did not say the laws contain an arrow anywhere. He said the world has one and the laws do not, and that somebody was going to have to account for the difference. 100 years later, nobody has managed it, and it is probably not for lack of trying. So if nothing in the laws forbids the reverse, then why do you never once see it happen? Not rarely. Not once in 80 years. Never. But you do see it happen, and that is the obvious answer to throw back. You are right to reach for it, because what you see every day looks overwhelming. Hot drinks cool down on the counter and never warm back up again on their own. Broken things stay broken on the floor where they landed, every single time. Milk goes into the coffee and never once comes back out of it. Has it ever, for anybody, anywhere? You have watched this every day of your life without a single exception. So whatever the equations happen to say, the world clearly has a direction in it. So here is the part that changes the shape of that answer. The one-way process you keep pointing at does not appear to be a law at all. It appears to be a count, a tally of arrangements, and nothing else at all. There are astronomically more ways for that milk to be spread through the cup than there are ways for it to be gathered in one spot. So the spread version is the one you get every single time you stir the cup. That happens by weight of numbers, not by prohibition. Think about being dealt 5 cards across somebody's kitchen table on a Saturday night. What were the odds of exactly that hand? Any particular hand of 5 is wildly improbable, and yet you are sitting there holding one of them. Something had to come out of that deck, and it came out as this. Nothing anywhere in the rules forbids the royal flush from landing in your hand tonight. It is simply outnumbered by every other arrangement the deck can produce. So that is the entire standing of the thing you have called irreversibility your whole life. And in 2002, a group in Australia sat and watched the exception happen, right in front of them. They tracked a single microscopic bead suspended in a drop of water, measuring it over extremely short intervals. They recorded stretches where the whole system ran the wrong way, briefly, against the direction everybody expects it to run. Nothing broke, no alarm sounded, no rule anywhere was bent. No law appears to have been violated, because there was likely no law sitting there to violate. So how solid is that direction? The one you have been counting on your entire life. Nothing in the laws forbids your coffee from getting hotter on its own. It is only unlikely. Unlikely and forbidden are not the same word. This objection is not new, and the man who raised it likely did it to a friend's face. In 1876, Joseph Loschmidt put a question to Ludwig Boltzmann that has never been fully answered by anybody since. Boltzmann had built the account you just heard. Disorder rises because there are simply far more ways for a system to be disordered than ordered. Loschmidt appears to have seen the hole in it immediately. He did not need a decade of study to see it. Suppose you could reach into a room and reverse the velocity of every single particle in it at once. Nothing in the underlying rules of physics forbids that state from existing. Every particle in the room would retrace its own path exactly, step for step. The whole room would run backwards, with disorder falling instead of rising. So how does a one-way conclusion ever come out of two-way rules? It probably cannot come out of them by logic alone. Something has to be smuggled in somewhere along the line. But what exactly? And by whom? Think about a tin of paint sitting on a bench after you have stirred the colour all the way through it. Every molecule of pigment took a specific path to where it now sits. Every one of those paths would work perfectly well run in reverse. Not one of them is forbidden by anything in physics. There is not one molecule anywhere in that tin that would object to the return trip. And yet, you will never see those colours separate back into layers. Not once. No matter how long you stand over the tin. Nothing in the rules is stopping it from happening. So what is stopping it from happening? Something in the world must be. Boltzmann never resolved this. Not fully. Not in his own lifetime, anyway. He worked at the problem for years. He never managed to close it properly, and neither has anyone else. What he had was a statement about likelihood, and nothing firmer than that. Loschmidt had pointed out that likelihood always needs a starting point to be measured from, which is where the whole question quietly moves out of the laboratory. And it goes considerably further than that. If the direction is not written into the rules, then it has to be coming from the conditions instead. And those conditions appear to have been set somewhere you cannot reach. Somewhere nobody can reach. And nobody ever will be. So follow that direction back to wherever it came from, and watch how far you have to travel before you arrive. If the rules do not carry an arrow, then the arrow has to be sitting somewhere in the starting conditions. That is not a dodge, and it is not a piece of hand-waving either. It is a specific claim about a specific state of the world. That claim has a name. So what exactly is being claimed here? In 2000, the philosopher David Albert set it out cleanly and gave it a name. He called it the past hypothesis, and that phrase has stuck to the problem ever since. The claim itself is short enough to say in a single breath. The universe began in a state of extraordinarily low disorder, far lower than anything you see around you now. Everything you experience as the flow of time is likely that single condition unwinding, slowly, ever since it was set, ever. So is that a law of nature? It is not, and nobody working on it claims otherwise. It appears to be a boundary condition, one that was added by hand. The equations on their own do not produce what we observe, so somebody had to put it in there by hand. Think about a garage that you spent an entire weekend organizing properly, top to bottom, every tool back on its own hook, every screw sorted into a labeled jar, every offcut swept up off the floor and thrown out. From that afternoon onward, only one direction is really available to that garage, and you know exactly which one it takes. Nothing in the physics of a wrench prevents that wrench from finding its own way back onto the pegboard. Nothing at all forbids that. It is simply that the tidy arrangement happened to be the rare one out of billions. The room has been leaving it ever since, steadily, on every single day since then. So the arrow running through your own life does not appear to be generated by anything happening now. It was probably loaded once, a very long time ago indeed, and you happen to be living somewhere inside the unwinding of it, which raises the one question that Albert made completely unavoidable for everybody after him. Why did the universe start that way in the first place? Nobody knows the answer to that. Not one person on this planet has a good answer to it. And notice where you have to be standing to even ask that question in the first place. Now look at what that one starting condition is actually paying for. The bill turns out to be a good deal longer than you would guess. You probably assume that memory is a completely separate thing from thermodynamics, sitting in another department. Your recollections feel like a mental matter. Something happening inside your head, entirely unrelated to heat and disorder. They are likely not separate. Not in the slightest. So what does the act of remembering actually cost? In 1867, James Clerk Maxwell described a small creature. It has been arguing with physicists ever since he first put it down on paper. Put a small intelligent being at a doorway between two halves of a container of gas. Let it open that door only for the fast molecules going one way and the slow ones going the other. It sorts the molecules, one at a time, hour after hour, without stopping. Is that even allowed to happen? One side of the container heats up, the other cools down, and disorder seems to fall for free. The way out of that puzzle took physicists the better part of a century to find, and the answer, when it finally arrived, turned out to be about memory. To sort anything at all, the creature first has to know which molecule is coming at it down the pipe. Knowing means recording. There is no way around that step whatsoever. Recording means the record has to start out blank, sitting in a known and orderly state. And a blank orderly state is exactly the rare and expensive thing the past hypothesis was brought into supply. Think about the crumpled receipt sitting in the pocket of your coat right now. It exists, because a purchase left a mark on paper that was completely blank beforehand. You have never once found a receipt in that pocket for something you have not yet bought. Not because the future is forbidden from leaving marks. It is that a mark requires a surface that was empty first, and empty surfaces appear to be available in only one direction. Your brain appears to be running that same arrangement, in tissue rather than in paper. So why is it that you remember only backwards? Because recording anything at all consumes the very same rare condition that gives disorder somewhere left to expand into. The reason you cannot remember tomorrow is not a law of nature. It is a leftover. So the direction running through your entire life traces all the way back to one single condition. Now, try going and inspecting that condition for yourself, the way you would check anything else. You cannot do it. The reason appears to be a hard wall, not a shortage of funding or patience. In 1965, 2 engineers working in New Jersey picked up a faint hiss coming from every part of the sky. It was the same in every direction they pointed the antenna, without exception. It turned out to be the oldest light in existence, and nothing older than it has ever been seen by anybody. That glow is a surface, not a decoration on the sky, but an actual surface with a far side to it. Before that point in its history, the universe was opaque, all the way through. No light from any earlier moment ever made it through to anybody, and none ever will. Every telescope ever built stops dead at that wall. Every telescope that will ever be built is going to stop in the same place. And the condition doing all of the work in your life sits somewhere behind that wall. So can anybody ever get past it? The wall is not going to move for anybody. Think about a road accident that happened somewhere behind a thick bank of fog. You arrive afterwards and find the wreckage, the skid marks, the whole aftermath of it laid out across the tarmac. You can reconstruct a great deal from what is lying there on the road right in front of you. But the moment that actually started, the whole thing happened somewhere nobody could see. No amount of careful work on this side of the fog is going to put you back there. So how does anybody go about testing a claim about a state that cannot be observed at all? Mostly by its consequences, only by those, and never directly. That method is a good deal thinner than it sounds when you first hear it. If the early universe had been even slightly different, the sky above you today would look different. That is a real check with real teeth in it. But notice very carefully what that particular check is unable to do for you. It can tell you the condition was there, nothing beyond that. That much of it is solid enough. So what more could you possibly want from it? It cannot tell you why it was there in the first place, and it cannot tell you whether anything at all made it that way. But notice very carefully what just happened to your question. It did not get answered anywhere along the way. It simply moved somewhere else, which is all that actually happened here. You started with something perfectly ordinary, something from your own kitchen counter. Why does the milk never come back out of the coffee once it has gone in? You have been handed an explanation that points at a state of the universe nobody can see. That state sits 13 billion years upstream of where you are. And that state itself arrives with no explanation attached to it whatsoever. That appears to be a transfer of the problem rather than a solution to it. Think about a debt of yours that gets sold on to another collection firm across town. The letters stop coming from the first company. They start arriving from the second one instead, in slightly different envelopes. The amount owed has not changed by a single penny, and nothing whatsoever has been paid off. All that happened is that the paperwork moved to a different address, and you now have a considerably harder time reaching an actual human being about any of it. And that is roughly what the past hypothesis appears to do with the arrow of time. And there was a second objection to all of this, raised while Boltzmann was still alive to hear it said. In 1896, Ernst Zermelo pointed out something deeply awkward about closed systems left alone for long enough. Given long enough, they seem to return arbitrarily close to any state they have already passed through once before. The disorder in them does not rise forever. It cannot simply climb forever. It rises. Then it comes back down again. Then it climbs once more. The timescales involved are so long that they make the entire age of the universe look like a single afternoon. So, is that arrow of yours actually permanent? Or are you simply living on one slope of something far larger than anybody can see? Nobody can say. Not in either direction. There is no vantage point anywhere wide enough to check something like that. Boltzmann had no reply to Zermelo that satisfied anybody in the room. That list included Boltzmann himself, and this is roughly where the whole question sat for the next century. Until somebody worked out how to put a hand directly onto the arrow and move it. And in 2026, somebody finally did exactly that, and not on paper either. So what does it actually take to get your hands on the arrow of time itself? A team including Luis Pedro Garcia Pintos published work on this. They showed something specific. The arrow of time inside a quantum system is not fixed. It can be reshaped from the outside. By choosing how you measure a system, and when you measure it, you can apparently alter the direction in which its disorder develops, not reverse it wholesale, nothing that dramatic. You steer it instead, which is the word they use. Bend the slope, flatten it out, or tilt the whole run of the thing sideways. Sit for a moment with what that seems to imply about the status of the arrow. For 150 years, the direction of time has been treated as something the universe simply hands over to you. Finished. It is a fact you live inside and cannot touch, in the same category as weather or gravity. This work treats it as a setting instead. It is likely something with a value, something that responds to whatever you do to the system it belongs to. Think about a light switch on the wall. For your whole life, that switch has had two positions, on and off. And that seemed like the complete description of what light could do in a room. Then, one day, somebody shows you a dimmer fitted to the very same circuit. The light was always a quantity rather than a state. You simply never had the control in your hand before. That is what happened here. The arrow was always a parameter, and nobody had a handle on it until now. So does that mean anybody can go and undo the past now? No. It is worth being clear about that. What was studied here is a small system, tightly controlled, sitting on a bench in a laboratory somewhere. Nothing here reverses a broken cup on a kitchen floor, and nothing here brings anybody back. What the result removes is the last remaining excuse for calling that direction fundamental. A truly fundamental thing does not come with a dial fitted to it. So where does the big arrow come from? The one running through your whole life? Still from the same place as before. And that place is still closed to every one of us. The direction you call forward was set before there were atoms, and no one has found the hand that set it. There is a second result from 2026, and it pushes underneath everything you have just been told, further down than the last one managed to go. A group at Tampere in Finland had been working on a new wave equation, and they found something in it that they had not gone looking for. An asymmetry in how a wave develops shows up before you invoke thermodynamics at all, before you count anything. It is not counted, and it is not statistical. Nobody had to average anything to get it. It appears in the behavior of the wave itself, in the mathematics. That sits at a level well below any talk of disorder, or averages, or probability at all. Think about an old house that creaks at night. You have lived in one or known somebody who did. For years you assume it is the floorboards. Everybody does. Floorboards creak. Everybody knows that much. And the explanation covers everything you hear. Then, somebody who builds houses for a living comes over and tells you the frame itself is moving. The boards are simply the part you can hear from the couch. That is all they ever were. So what have you actually been listening to for all those years? That is the shape of this finding. Entropy was never the cause of the direction. It was only ever the noise the direction makes. Entropy was the part loud enough for anybody to notice. So how many separate arrows are you dealing with now? There is the statistical one, which turns out to be a count of arrangements and nothing more. There is the cosmological one, which traces all the way back to a condition that nobody can inspect or reach. And there may now be a third one underneath, sitting deeper than either of the other two. So is any of that settled yet? It is not. And here is the honest position on it. The Tampere work is genuinely new. It is one specific mathematical approach, and it has not been through the years of argument that settle these things. Nothing about it is finished. It still has to survive contact with everybody who will now line up to break it. But it does point at something that all of the older accounts had quietly assumed away. So the direction is possibly not something the universe developed over time, not a habit it picked up. It may be something the universe started out with, built into the way that anything moves at all. Now put the whole account down on the table and count up what you are actually holding. There are 3 sources of direction on that table, and not one of them is a law of physics. The first is statistical. It is only a matter of some arrangements outnumbering others. There is nothing deeper in it than that. The second is cosmological. It rests on a starting condition that sits behind a wall nobody can pass. Nobody knows why that condition held either. The third one is new and tentative. It appears to sit underneath the other 2, further down again. 3 legs holding up your entire sense of forward. Not one of them is bolted to the floor. But there is one exception to all this, and it cuts the other way. So is there anywhere at all where the laws themselves do pick a side? In 1964, James Cronin and Val Fitch were studying the decay of a particle called the Cairn. They were working at Brookhaven, out on Long Island in New York. They found that a certain decay happens slightly more often in one configuration than it does in the mirror image of that configuration. Slightly is the operative word. Very slightly, but reliably. The size of the imbalance is roughly 1 part in 500. That result won them a Nobel Prize, and it matters to you here for one specific reason. It is the only place anybody has ever found where the fundamental rules themselves seem to distinguish between one direction and its reverse. So why does that not solve the whole problem for you? The reason for that comes down entirely to scale. The effect turns up in one exotic decay and nowhere else. It runs at a strength of a fraction of a percent, inside particles that exist for billionths of a second. Nothing about it seems to explain why your coffee cools, and nothing about it explains why you cannot remember next Thursday coming toward you. What sits there is a genuine asymmetry, written into the rules themselves. It is also far too small and far too specialized to carry a human life on its back. So, what is the honest summary of where all of this leaves you standing? The summary is uncomfortable, and it does not get any better with study. The direction you experience every single day is real, measurable, and utterly reliable. And it is not fundamental. Not at any level anybody has managed to reach. So step back a moment. Count up what this last stretch of the road has taken away from you. You arrived at this act believing that time moves in one direction and that the movement is out there in the world. You believed it was a feature of the world rather than a feature of you. What you have instead of that is a statistical count, a tally of arrangements, nothing any deeper. You also have a starting condition that nobody can inspect or ever reach, and one small asymmetry in an exotic decay, far too weak to carry any real weight. None of that is a law of nature, and yet every part of it is entirely real and works every day. Think about a compass sitting flat in your hand on a hillside somewhere. The needle swings, then settles, then points somewhere, and you set off walking in that direction. What nobody tells you on that hillside is that the needle is not actually finding north at all. It is likely responding to a magnetic arrangement that was set up long ago, and that arrangement has been drifting ever since. The needle still works, and the walking still gets you somewhere real. There is simply nothing under it of the kind you had assumed was there. So, does the compass lie to you? The compass is not lying to anybody. So ask the question one more time, now that the act is done. If time itself is not moving, then what is? Here is the answer that this act leaves you holding at the end of it. What moves is probability and nothing else at all. Arrangements that were unlikely give way to arrangements that are more likely over and over. The entire parade of your life sits on top of that single fact. The cooling coffee, the aging face in the mirror, the memory of yesterday, and never of tomorrow. All of it is one long slope being descended. Change that one condition, and you would still be here. You would just have no way of telling which way you were going. And now the ground underneath you gets considerably stranger than any of that. In 1967, two physicists sat down and tried to write a single equation for the universe as a whole, gravity and quantum mechanics together, all of it written out on a single line. So did the two of them manage it? They did. They wrote the whole thing down, and then they looked closely at what they had actually written down on the page. Here is what those two men were actually doing in 1967, because the detail matters to you. Bryce DeWitt and John Wheeler were not out hunting for a strange result to publish. They were trying to combine gravity with quantum mechanics, a problem that had resisted every serious attempt for decades. What the two of them wanted was one equation covering everything at once. Not one room, not one galaxy either. The whole thing at once, with nothing at all left over on the outside of it. And that last part is probably where all of the trouble starts for them. Every equation of motion you have ever seen describes how something changes against a clock. And that clock always sits outside the system being described. It is never part of what it measures, never in among the things at times. A pendulum swings against the clock, hanging on the laboratory wall behind it. A planet orbits against a calendar that somebody down here is keeping. The clock is always somewhere else, sitting outside and watching. Now try writing the equation for absolutely everything there is. So, where exactly do you put the clock now? There is no outside left at all. Nowhere to stand. Think about trying to photograph your entire house and getting the photographer into the picture as well. You can shoot every room in the place and every hallway, every corner of the roof and every inch of the yard outside. The one thing that seemingly cannot appear anywhere in that picture is the position you are shooting from. The camera has not failed you here. It is that the frame has no room in it for the thing that is making the frame. The equation those two wrote appears to have the same shape of problem, and it is likely not an accident of the method they happen to use. So what actually came out of all that work? They produced an equation that describes the universe in full, and in it, nothing changes. Not a small term hiding in a corner, and not a large one either. Not a term that quietly cancels further down the page. Nothing of that kind. Not anywhere in the line. There is simply no place in that line where the word could go. Everything that has ever happened is already in it, and none of it is going anywhere. And your first response to that is the obvious one. Those two men must have made a mistake somewhere in the working. Is that not the sensible thing to think here? But they did not make a mistake, and the way you can be reasonably sure of that is worth following through. When a result looks absurd on its face, the honest move is to go hunting for the error in it. Physicists spent years doing exactly that. Decades of it, and by more than one group. The equation held up under every bit of it. It is likely one of the most attacked lines in the whole field. It has been checked, re-derived, and attacked from a dozen directions for well over 50 years now. The missing term has never once come back. Not in any derivation anybody has tried. So the question itself changed shape. It stopped being a question about where those two men had gone wrong. It became something harder. What would a universe like that actually look like to somebody standing inside it? In 1983, two physicists, Don Page and William Wouters, put forward an answer to that question. Their move was simple enough to state in one sentence, which is rare in this corner of physics. Stop asking what the time is. Start asking what one part of the universe reads at the moment, another part is sitting in a given state. That is a conditional question rather than an absolute one. And conditional questions apparently have answers even in a place where the absolute ones do not. Think about a man working a line in a plant where there is no clock anywhere on the wall. You have probably worked a shift next to that man. Ask that man how long he has been at it, and he will not tell you 4 hours. He will tell you he is 3 pallets in. Second break of the shift not taken yet. He is not estimating the time for you, and he probably could not do it if you asked him to try. He is reading one part of that room against another part of it, and it works, because the pallets and his shift are tied firmly to each other. Take those pallets away from him, and the question stops having any answer at all. So, what is he actually reading off that room, if not time? So what does all of this leave you holding at the end of it? It gives you a universe with no clock hanging anywhere outside it. The parts of it still hold definite readings relative to one another. Nothing in it is frozen, and nothing in it is flowing either. And that one distinction is where all of this starts to reach you personally. Take that mechanism apart on the bench and look at how it works. The shape of it matters far more here than the mathematics does. You start by splitting the universe into two pieces. One piece of it you decide to call the clock. You do that purely for convenience and for no other reason at all. Everything else in existence you call the rest of the universe. Neither piece is special. The split is your own choice, and it is likely not a feature of the world at all. Then you ask one single question, and only that one. When the clock piece is sitting in this particular state, what state is the rest of it in? That is the entire question, from start to finish. Ask that same thing for every state the clock is able to take. Then write all of those answers down in order. What comes back at you from that list looks exactly like history. It looks like one thing after another in a clean order. Think about a card file in a grey metal cabinet, the kind that used to stand in the corner of every office. Every card in it is sitting in that drawer at the same time. Nothing anywhere inside that cabinet is moving. But pull those cards out of the drawer one at a time. Match each number against whatever is written on the card, and a sequence appears right there in your hands. So where did that sequence come from? Nowhere but out of that drawer. That sequence is real. You are not inventing it as you go, and it was in those cards before you touched them. Nobody handed that order to you. It was probably sitting in the correlations between the numbers and the contents all along. And that drawer never moved at any point. So that is the whole mechanism, laid out on the table. Now notice very carefully what that mechanism does not require in order to work. It does not need anything to flow anywhere. Nothing in it has to move. It does not need a moment called now to be picked out of the pile and lit up somehow. There is no spotlight anywhere in the mechanism. What it needs is correlation, and nothing besides that. And correlation appears to be a completely static property of a pair of things. So, where does that leave the equation those two men wrote in 1967? Exactly where it has sat since 1967. Untouched by any of this, and still standing there. In the equation that describes the universe as a whole, there is nowhere to write the word when. So far, all of this is a mechanism written out on paper, and nothing more than that. You are entitled to ask whether anything in an actual laboratory behaves that way. It is exactly the right question to ask here. In 2020, Alexander Smith and Mehdi Ahmadi published work in Nature Communications that goes at exactly that question. They treated a clock in exactly the way the mechanism demands that you treat it. Not as an instrument sitting outside, not as something reading off a value. As a quantum system sitting inside the situation, correlated with everything around it. Then they asked a plain question. So what does a clock like that actually read? The answer they got back has two parts to it, and the second part of it is new. A quantum clock records the ordinary slowing that you already know about, the sort that comes from moving quickly. That part was expected, and nobody in the field was surprised by it. But it also records a second effect, and that one has no equivalent anywhere in the older picture. Put the clock into a superposition of two different speeds at once. Can a clock even do such a thing? Apparently it can, and the two of them worked out exactly what follows from that. Not two separate clocks standing side by side on a bench. One clock, sitting in both states at once. What it reads is likely a blurred proper time, spread out across the possibilities. And the width of that spread is measurable. It seems to have a number attached to it. Think about the speedometer in your truck. It shows you one number. The truck is doing one speed. That is the whole arrangement. Now imagine a needle sitting across two readings on that dial at once. The width of that smear is a real quantity, and you could write it down. That appears to be what a quantum clock does with its own aging. So what does all of that give you, beyond the mathematics on the page? It gives the mechanism teeth, real ones, with numbers behind them. Time as a relation between correlated systems is no longer just a story. Not about a static universe, not about anything else. It makes predictions about what a real instrument will read, and those predictions differ from the older ones. And once time becomes a quantity that a system carries, somebody is eventually going to ask what it costs to carry. The mechanism did not stop at time. And this is the point where the whole thing gets away from you entirely. In December 2025, a group in Naples led by Tommaso Favalli took that same construction. They pushed it further along, further than its own authors had ever taken it. If correlations between subsystems can produce the appearance of time, they asked, then why stop the argument at time? Why not space as well? They started from a universe with no time in it, and no positions in it either. Nothing located anywhere in it, and nothing happening at all. Then they let the parts of that universe correlate with one another. And then they looked at what an observer sitting inside it would report back to you. What comes out at the far end of that working is a three-dimensional world, with events running in order all the way through it. Not a diagram of such a world, but a full working description of one that holds together. And it reproduces effects you have already met earlier in this account. That includes the slowing of clocks down inside a gravitational field, which you met about an hour ago. Think about the wiring diagram for a house you're thinking of buying. It contains no rooms, no walls, nothing on it that you could stand inside of. What that sheet holds instead is a list of what connects to what, which switch runs out to which fixture, and which circuit carries which load. Hand that sheet to an electrician who has never once set foot in the building. He can tell you the layout of the whole place inside an hour. The rooms themselves were never drawn anywhere on that sheet. They were implied by the connections. There was only one arrangement those connections would fit into. That is roughly the claim now being made about the world you are standing in tonight. So how much of your original furniture is actually left standing by this point? Not the flow of time, not the moment called now, and not the direction. And now, it appears, not even the room that you are sitting in tonight. Everything you took for the stage itself now turns out to be a report about relationships between things. Which raises the one question nobody bothered asking while the stage still seemed solid. If time is produced rather than simply given to you, then what does producing it actually cost? In November 2025, a group answered that question with an actual number, and the number is worse than you would guess. The work came out of Oxford and appeared in Physical Review letters. Florian Wadia was lead author, with Natalia Aries running the group behind it. What the team built is the smallest honest clock that anybody has ever managed to make. It runs on single electrons hopping between quantum dots, one electron at a time. Every hop is one tick, and that is the entire instrument. Nothing simpler exists anywhere in the world. Nothing simpler could. Then they went and measured two separate things about that instrument, and this is the point where it turns on you. First, the energy the clock burns simply by running. Call that one the cost of producing the ticks in the first place at all. Second, the energy it takes to extract those ticks from the device, not to make them. Call that the cost of getting them out, into a form that a person could read off a screen. So how far apart are those two numbers? They are not close, not remotely close, and not off by any factor you could shrug at. Reading that clock can apparently cost up to 1 billion times more energy than simply running it does. Think about the furnace sitting down in the basement of your house. It burns fuel, you pay for that fuel, and that is the cost you expect to carry through every winter. Now imagine that simply finding out how much it had burned cost you 1 billion times the fuel bill itself. Would you keep checking that meter every single month? You would stop asking. You would just let the thing run and never look. Because in that arrangement, the checking is the expensive part rather than the burning. And that is roughly the arrangement these researchers have now put a hard figure on. So, where exactly does that number leave the picture you were handed a few minutes ago? Time was a relation holding between correlated systems. Fine, you can live with that much of it. But reading that relation, turning a bare correlation into a number that somebody actually knows, takes energy out of the world, and it does not give any of that energy back. Reading the clock costs 1 billion times more than running it. Knowing the time is more expensive than spending it. So why should reading anything cost you energy at all? The question probably sounds naive to you. It is not, and the answer runs a good deal deeper than that one instrument. Information is physical. That is not a slogan anybody invented. It is a measured fact about the world. That connection goes back to 1961. That year, Rolf Landauer showed that handling data carries a thermodynamic price with it, and that price is not a metaphor. The price comes in joules, and somebody somewhere has to hand those joules over. What the Oxford work adds to that is the other half of the ledger entirely. Landauer himself was concerned with erasing information, with the act of wiping something out. This new work is about extracting instead, and extracting appears to be the expensive direction to travel in. So, where does that cost actually come from? Here is the shape of the thing. A single tick inside that device is a very small event indeed, about as small as events get. One single electron changes its position. The energy involved in that sits close to the smallest quantity nature deals in at all. But you cannot see an electron. Nobody has ever seen one directly, and nobody ever will with their own eyes. For you to know that the hop even happened, the device has to amplify it into something that a person or a machine can register. An amplification is never free anywhere, in any device. It drags that signal up out of the noise around it, and the dragging is the part that costs. Think about weighing a sack of grain out in a barn somewhere. The sack already has a weight, whether or not anybody in the world knows the number. But to find that number out, somebody has to bend down and lift the sack up onto the scale. And lifting is work in the physical sense. The weight itself was free. Learning what the weight actually is was not free at all. So notice very carefully what all of that separates out for you. There is the world doing whatever it happens to do, entirely on its own, and then, separately, there is somebody finding out about what it did. And which of those two turns out to be the expensive one? Those are two entirely different processes, with two different bills attached, and only one of them has ever been paid on your behalf. Now take that finding off the laboratory bench and carry it into the place where you actually live. The Oxford result concerns one specific device. A careful person would probably stop reading right there and leave it alone. But the reasoning underneath it does not appear to depend on quantum dots at all. It depends on exactly two things, and nothing beyond them. There has to be a system that changes, and there has to be something else that registers the change happening. Wherever those two things exist together, the same accounting seems to apply to them. So who is paying? So run down that list and see where you land on it yourself. A rock sitting out in a field reads nothing, registers nothing, and therefore owes nothing to anybody. So a rock like that pays nothing. And it likely has no time at all, in any meaningful sense. A thermostat on a hallway wall registers something, in the crudest possible way. So a thermostat pays too. A very small bill, but a real one all the same. Every cell in your body that responds to what happened a moment ago is registering something. Every single one of them is paying for it. In January 2026, a paper in the International Journal of Theoretical Physics pushed that reasoning further still. It treated the accumulation of correlations itself as the clock, not something that measures time. Something whose growing is what the word actually refers to. Something whose steady growth is what the word time amounts to in the first place. Does that sound like a stretch to you? It is not one. Think about the electricity meter bolted to the side of your house. It does not care what you run inside the place. It does not care why. It does not care whether anybody is even home that week. Everything that comes into that house passes through the meter first. The reading on it only ever travels in one direction. You cannot spin that dial backwards by turning all the lights off for a month or for a year. All you can do is change how fast it climbs. That is the entire extent of your control. And that is roughly what your own body has been doing since the first day it started running, without a pause. So what should any of this be called now? The old word for it turns out to be the wrong one entirely. So the word itself has to change, and the change is not a cosmetic one. You have carried one single picture of time around with you for your entire life. Time is the room you happen to be standing in, and nothing more. The container that everything else in the world sits inside of. The backdrop against which things happen to you. Neutral and free, and simply there for the taking. So how much of the last 2 hours actually supports that picture? Almost none of it seems to hold up when you press on it hard. There is no universal rate anywhere on this planet, or off it. There is likely no shared moment that two separate observers could ever be made to agree on. There is no direction built into anything at the bottom, and there is no variable for it anywhere in the deepest description that anybody has ever managed to write down. What there is instead is a cost, a real one, with a number attached. It was apparently measured in Oxford in 2025, written up, published, and it is sitting in the record now. Something somewhere has to pay to produce the correlations in the first place, and then something has to pay all over again in order to read them. Think about driving a long stretch of road that has no toll booth anywhere on it. No barrier ever comes down in front of the car anywhere. Nobody stands out at the roadside to take your money as you pass. You drive that stretch exactly the way you would drive any other road in the county. It feels like open highway the entire way along, mile after mile. Then the statement arrives at the end of the month with your plate number printed at the top of it. Every single trip you made is listed out on it, line by line. So was that road ever free? It never was. Not for 1 minute of it. That road was metered the entire time you drove it. The absence of a booth told you nothing at all about whether you were being charged for the privilege. So, what does all of that make the thing you have spent your life standing inside? It is probably not a room that you occupy for a while and then leave. It is not a backdrop that somebody hung up behind you. Not a stage that was set up before you arrived and will still be standing after you have gone. Time is not the stage. Time is the bill. But that is just a figure of speech, you might reasonably say, and it is a fair objection to raise. Calling time a bill probably sounds like the kind of line that closes out a chapter and means nothing at all underneath it. Metaphors are cheap, and anybody can produce one of those on demand. So here is the test that separates a metaphor from an actual claim about how the world works. Does the thing you are describing come with units attached to it? A metaphor never has any units, and it never will have. You cannot weigh regret on a scale. You cannot pour loyalty out of a jug, and nobody has ever measured it out by the liter. And if somebody tries it on you anyway, you know straight away that they are decorating rather than describing anything. This particular claim does have units attached, and they are entirely ordinary ones at that. Erasing one single bit of information at room temperature costs at least 3 billionths of a billionth of a billionth of a joule. That is the smallest price the universe allows anybody. That figure was worked out in 1961, and it has been confirmed in the laboratory more than once since then. It is a hard flaw, not an estimate, nothing that gets revised downward later. No amount of cleverness has ever got underneath that number. Nobody has managed to do it in 60 years of trying. Think about taking your truck into the shop when something has started going wrong with it. The mechanic can look up at you from the bay and say that it will be expensive. Does that tell you anything at all? That tells you almost nothing you could act on, or he can hand you a printed sheet with the parts listed out, the hours listed out, and a total sitting at the bottom. The second one is a completely different kind of statement. You can argue with a sheet like that, you can check every line on it, or you can simply refuse to pay the thing altogether. So which of those two kinds of statement is the one about time? Somebody walked into a laboratory and measured the joules involved in it. Somebody has put an actual number on what it costs a system to know what time it happens to be. So that is not a figure of speech. It is not a rhetorical flourish either. What you are holding in your hands is an invoice. So count up what this last stretch of the road has taken from you, because it took the largest thing yet by some distance. The earlier stretches of this removed properties from you, taking them one at a time. A shared rate went first, then a shared moment between any two observers, then any direction built into the laws of physics themselves. But through all of that, you could still hold on to one assumption sitting underneath the rest. Whatever time turned out to be in the end, it was at least something. It was a quantity. Something with a size to it. Something you could actually write down on paper. A variable that turns up somewhere in any description of the world. This last stretch of road has now removed that assumption as well. So what is actually left of that variable itself by now? In the deepest equation that anybody has ever written down, there is no such variable at all. None at all. What stands in its place instead is a relation holding between correlated parts of the world. And that relation is produced at a cost. A cost that was measured out in a laboratory in 2025. In joules. On a bench. Think about the fuel gauge sitting in front of you on a long drive across open country at night. You watch that needle drop, and you think about time passing. You think about how many hours are left in the drive before you have to pull off the road and stop somewhere for the night. But that needle is not reading hours at all, and it never has been reading them. All that it reads is how much fuel is still sitting down in the tank behind you. The hours were probably never the quantity that gauge was tracking at all. They were only ever your own interpretation of a level dropping slowly in a tank. And the level is likely the only thing that was ever there. So ask the same question one final time, now that everything else has gone. If time itself is not moving, then what is? Nothing anywhere is moving at all. Something is simply being spent, steadily and quietly, and none of it ever comes back afterwards. And now comes the very last question of all. It is the one this entire account has been walking toward from the first minute. If something is being spent here, then what happens to all of the part that has already been paid for? Nothing happens to it at all. Nothing whatsoever happens to any of it. That is the answer the physics gives you back. And it probably takes a moment to see why it is the worst one available. In 1908, Hermann Minkowski stood up and gave a lecture in Cologne that changed the way physicists draw the world. He took the results of the previous 3 years and pointed out what they seemed to imply about the underlying geometry of the world. Space and time are likely not two separate things at all, and probably never were. They appear to be one four-dimensional structure. Events sit inside that structure at fixed coordinates, in the same way towns sit at fixed points on a continent. Nothing in there wanders off later, and nothing in there likely dissolves. So notice carefully what all of that does to your own past. Where does it go? If an event has a coordinate in that structure, then it does not stop having one later on. Coordinates do not expire, and nothing in the structure revokes them. Does a town cease to exist simply because you drove out of it last Tuesday afternoon? Obviously it does not. The idea is absurd the moment you say it out loud. It is exactly where it has always been, doing whatever it happens to be doing today. Your distance from that town says nothing about whether it is still there. And on this picture, exactly the same thing appears to hold true for the afternoon on which you turned 11 years old. Think about the town you grew up in. Not the memory of the place. The actual streets. The actual houses on them. That town is standing right now, this very second, while you're sitting here listening to this. The streets are all there. Exactly where they were. Somebody is walking down one of them at this exact moment, carrying groceries home right now. Your distance from that place is a fact about where you are, and not a fact about the place itself. Nothing about your leaving that place ever removed a single brick from any of it. So what is the actual difference between that town and that particular afternoon? The only difference between them is which direction the distance happens to run in. Every version of you that ever existed is still sitting at its own coordinate, and not one of them can be reached. But existing and being reachable are two entirely different properties of a thing. This is likely where your comfort runs out. People hear that the past is still there and they take it as consolation almost immediately. It sounds like good news, and for a moment it is. Nothing was lost after all, they think. Everything is preserved somewhere out there, safe and whole and untouched. That reading gets the first half of it right, and it gets the second half badly wrong. Preserved is not the same word as available, and it never has been. Those two words are not even close to each other in meaning. The structure that keeps your 11th birthday sitting in place is the same structure that puts it permanently out of your reach. Since 1905, that limit has been known, and it has never once been broken by anything anybody has ever measured. Nothing in this universe carries information faster than light does, which means that from the chair you're sitting in right now, two whole sets of events are already fixed. There are the events that you can still affect from here, and there are the events that can affect you. So, which of those two sets holds your 11th birthday in it? Neither one of them does. That afternoon can reach you, and it does so every day of your life. You cannot reach it at all, not by any route. Think about a bank account you closed 20 years ago at a bank that has since been bought and sold twice over. The records still exist. Every last one of them is still intact in there. They are sitting in an archive on a server somewhere, complete, with every single transaction still intact. Nobody destroyed anything in that archive. Nothing was shredded, and nothing was burned. You simply have no route to any of it left, and no amount of wanting produces one now. Could you get to those records if it mattered enough to you? You could not, and neither could anybody else. So, what does it actually mean to say that the afternoon is real? It means the coordinate is occupied. It does not mean there is any road running to that coordinate. And this is the part that people quietly skip over when they reach for the comfort in all of it. Preservation without access is not a gift. It never was one, and it never will be. Now you may well be thinking that all of this stopped being physics somewhere back there, a few minutes ago. That the whole account quietly drifted over into philosophy while you were listening. And philosophy, you might reasonably say, is where arguments go to sit when nobody can ever settle them. It is a reasonable enough suspicion for anybody to have at this point in the evening. It is also probably wrong about who is doing the arguing here. So who is actually running this dispute in 2026? It is not the people you would expect it to be, not by a long way. The question of whether the past and the future exist has a name in the literature. It also has two camps standing behind it, and those two camps do not get along at all. One camp holds that only the present moment is real. On that view, the past has genuinely gone out of existence altogether. The other camp holds that all events exist alike. On that second view, your present is simply where you happen to be standing at the moment, and nothing more than that. That disagreement is live right now, this year, and the people running that disagreement are working physicists with careers on the line, not commentators standing on the sidelines. They publish papers in the physics journals, they attack each other's models in print, by name, in public. They propose experiments that might one day settle the thing for good. Does any of that sound like philosophy to you? Think about two structural engineers standing underneath a highway bridge, arguing with each other about how the load actually distributes itself through the thing. One of the two men says the deck is carrying most of the weight. The other says the cables overhead are doing nearly all of the work. They are genuinely at odds over it, and neither of the two has managed to close the question yet. And all the while, that bridge is holding up perfectly fine, with loaded trucks crossing over it every single afternoon. So, does an argument like that one mean nothing at all is known about the bridge? It means close to the opposite of that, and the reason is worth holding on to. You do not get a hard disagreement about a structure unless that structure is solid enough to be worth disagreeing about in the first place. So, here is the objection that actually matters to you, the one you have probably been holding on to for a while now. If every event already sits at its own coordinate in that structure, then your own choices are sitting there too. And nothing you decide to do this evening is open in any real sense of the word. That conclusion probably feels forced on you by everything you have heard over the last 2 hours. It is worth slowing right down on that one. 2 separate ideas have quietly been welded together somewhere along the way, and the 2 of them need pulling apart carefully. One idea is simply that the future exists. The other is that the future is fixed regardless of anything you do about it, either way. Those are not the same claim at all. And the second of them is a great deal older than anything you have heard tonight. In 1814, Pierre-Simon Laplace described an intelligence that knows the position and motion of every particle in the world. Such a mind, he said, could calculate the entire future of the world from that information alone, every event of it, all the way down to the end. That was a question about determinism, and it was live long before anybody drew a 4-dimensional structure on a blackboard. So, what has actually changed since Laplace? Nothing in the last hour has added anything at all to that old question. Not one single thing that Laplace did not already have. Think about a verdict being handed down in a courtroom on an ordinary Tuesday morning. That verdict is fixed now, permanently. It will not change, and nobody can appeal the thing back into uncertainty again. But it is likely fixed because of what somebody actually did on one particular night, several years earlier. So, does the permanence of that verdict mean the man in the dock was a passenger in his own life? It does not. It means very nearly the opposite. That verdict is permanent precisely because of what he did, and for no other reason. So, what does a choice of yours actually require in order to count as a choice at all? It seems to require one thing: that what you do actually makes the difference to how the thing turns out. It does not require that the outcome sit undecided somewhere out ahead of you, waiting around to be filled in later. There is one quantity in all of this that only ever goes up on you and never once comes down. It is not time itself, which has been taken apart in front of you piece by piece over the last 2 hours. And it is not motion either, since nothing anywhere in this account has been shown to move at all. So, what is left in the world that actually grows? The number of correlations. The running count of all the things that have become tied to other things. Every interaction anywhere in the world leaves one behind it. And nothing anybody has ever found removes them again afterwards. In 1929, Leo Szilard worked out something that still holds. Information about a system can be turned into physical work, into a force that actually moves things in the world, which means that correlations are probably not just bookkeeping written on a page somewhere. They are stock, held on a shelf. They are worth something to somebody, in the end. Something real appears to be accumulating in the world, and the pile of it only ever gets deeper with the years. Think about the hands of a man who has worked with them every day for 40 years straight. The scars on the backs of them are a record of something real. Each one of them corresponds to one particular afternoon in a shop or a yard somewhere. A particular piece of steel on the bench. A particular moment of carelessness, or of plain ordinary bad luck on the day. Does anything about those hands ever run backwards for him? Nothing does, and nothing ever will. They do not smooth over during the winter and roughen up again when spring comes around. The count goes in one direction only, and those hands are likely the ledger that the whole count is written down in. So, what have you actually been doing with yourself over all these years? If you have not been traveling forward through anything, you have not been traveling anywhere, you have not been passing through anything at all, in any direction. What you have been doing is accumulating correlations with the world around you at a rate set by your own body. And every single one of those correlations had to be paid for out of something real. And that changes what you are inside this picture. It changes it completely, and not at all in your favor. So put yourself back into the picture now, and look carefully at what position is actually left for you in it. All evening long, you have probably been imagining one particular arrangement of things. You never once noticed that you were doing it? Time sitting over on one side of the room, doing something all on its own. You sitting on the other side of it, going along with whatever it happens to do. A passenger, in other words. Nothing more than that, in your own picture. Somebody carried forward by a process that would run identically whether or not you had ever been aboard it. So, how much of that whole arrangement is actually left standing now? Every word of that picture has come apart over the last 2 hours. There is no process carrying anything anywhere at all. And there is no forward left in the world for it to carry you along. What that Oxford measurement back in 2025 puts an actual figure on is not something happening to you. It is something happening at you, right where you sit. The difference between those two small words is likely the whole point of everything tonight. Think about the card reader sitting on the counter of any shop you walk into on a Saturday. You probably picture yourself as the customer standing there, handing something over across the counter, then walking back out onto the street with your bag. But that reader is not an onlooker at the transaction. It is not standing there on the counter watching something happen in front of it. It is the place where the transaction actually occurs, and it is the only such place there is. Nothing is charged anywhere else in the world. Not 1 cent of it is charged anywhere else on the planet. The money does not pass through that machine on its way to somewhere better or more important. That machine on the counter is the location of the event itself. Take that box off the counter, and there is no event at all, anywhere. Does the charge go through somewhere else instead? It does not. Nothing goes through at all. So, which of those two things are you in this arrangement? You are not the customer standing in that shop. And you are not the money moving across the counter either. You are not moving through time. You are the place where the payment is made. Now notice something genuinely strange about everything that you have just been told over this evening. In 1955, a few weeks before his own death, Einstein sat down and wrote a letter to the family of a lifelong friend who had just died. He told them that the division between past, present, and future is a stubborn illusion. However firmly people hold on to that division, he told them, it remains an illusion all the same. And he apparently meant it kindly. Was any of it a comfort to the people who received that letter? It was certainly written to be one. That letter was written to console a grieving family in the days around a funeral. Consolation was apparently the entire purpose of the thing when he wrote it. Now read that same line again tonight, after everything you have sat through in the last 2 hours. It probably lands as a sentence of a completely different kind now, meaning something else entirely. Nothing about the words themselves has changed at all since he wrote them down. What seems to have changed is only which end of them you happen to be standing at. Think about the lock sitting on the front door of your own house. It is one single mechanism, one set of pins, one single key that turns in it, cut for one particular door. From the outside, that lock is the thing keeping strangers away from your family while you are asleep. From the inside, if somebody else is holding the key and you are not, it is the thing keeping you inside that house. Nobody went out and redesigned that lock in between the two descriptions of it. It is the same object either way, unchanged and unmoved. So, which reading of this is the correct one? Both of them are likely correct at the very same time, and that is the genuinely uncomfortable part of all this. The statement that no moment is privileged means one thing. Your worst afternoon is preserved out there somewhere, exactly as it was on the day it happened. It possibly means your best one is preserved out there too, in precisely the same way, sitting on its own coordinate, untouched. So which of those two readings does the physics itself lean toward? Neither one, as far as anybody can tell. It does not lean either way, and it is never going to tell you how to hold any of it. Go back to where all of this started tonight, because that opening fact reads very differently now. 2 hours ago, you were told that the top of your body and the bottom of it run at different rates. It was presented as a fact, and it went past you fairly quickly at the time. In 2022, that difference was resolved cleanly across a single millimeter of atoms in a trap. At the time, it probably sounded to you like a curiosity out of somebody else's laboratory. It is likely not a curiosity at all, and it never was. Underneath everything you have heard in the hours since, that measurement seems to say something else entirely. Your skull and your ankles have not simply been keeping slightly different time from one another all these years. They have been running separate accounts. 2 separate ledgers, kept apart, and never once reconciled with each other. Each part of your body sits at its own height above the ground. Each part moves at its own speed through the day, and each of them accumulates its own correlations with the world, at its own private rate. And there is no central ledger anywhere in your body that adds all of those separate counts up into one number called your age. So, where exactly would such a number be kept in you? Think about a house somewhere where the foundation has settled unevenly over 40 years of hard winters. One corner of it dropped a little further into the ground than the rest of the structure did. Nothing dramatic ever happened to that house. There is no crack anybody could point at, and from out on the street the place still looks perfectly square. But the doors on that side of the house stopped closing properly a very long time ago. Did anybody in that house notice the day it started? That house did not age as a single unit. It aged in parts instead, corner by corner, year by year. Those parts drifted apart from one another quietly, without any single day on which you could say it happened. So what is the correct answer when somebody at a table asks you how old you are? There is not one. There never has been one. What there is instead of a single number is a distribution. And you have been paying into every part of that distribution at slightly different rates since the day you were born. So put an actual number on your own share of the bill. A number does exist for it, and it has been measured. In 1948, 2 researchers, Seymour Keaty and Carl Schmitt, set out to measure something nobody had pinned down. How much energy does the human brain actually draw in order to run itself? The answer they came back with apparently surprised people at the time. It still surprises most people who hear it now. That organ makes up about 2% of your total body weight, and no more. And it takes roughly 20% of everything you burn in the course of an ordinary day. In ordinary units, that comes out at around 20 joules every second of the day. Continuously. Awake or asleep. Working or resting. For as long as you happen to last on this planet. Think about the small bulb sitting inside the door of the refrigerator in your kitchen. 20 watts is roughly that order of thing, give or take a little either way. Does 20 watts sound like a lot to you? It is a small, steady glow and nothing more than that. Nothing you would ever notice on a utility bill. It runs quietly inside a box that you open a handful of times a day and never think about. That is the standing drawer on you, permanently. All day and all night, every day of your life. Now ask yourself what all of that energy is actually buying you. It is likely not thoughts, at least not for most of the time. And it is not decisions either. Most of what that energy does down there never reaches you at all. What it seems to be buying is one thing only. The continuous construction of a present for you to go on standing in. That present of yours is assembled out of signals which arrived late, and which arrived badly out of order. It is sampled in windows only a few tens of milliseconds wide. Then it is edited into a clean sequence and handed over to you, as though it was simply the world itself. So what is the actual price of one single second of being somebody at all? It comes to about 20 joules, paid without interruption, by tissue that stops the moment the payment stops coming in? Have you ever missed a single installment on that? Not once in your entire life, waking or sleeping. And the receipt for every second of it is sitting there in your own hands. Walk through the house one more time now, before the lights go out for good. Check carefully what is actually left standing in each one of the rooms. You came into this evening holding 4 separate things in your hands. You could not necessarily have put names to any of them, but you were holding them. There was a shared rate so that everybody in the world ages together at one and the same speed. There was a shared moment, so that the word now would mean the same thing to any 2 people standing together in one room. There was a direction to it all, built into the world itself rather than into you. And there was a variable called time, appearing somewhere in the description of everything that exists. So how many of those 4 things are still standing at this point? All 4 are gone, not doubted, not weakened, and not merely called into question by somebody. Every one of them was measured away, one at a time, by instruments sitting on benches in Colorado, in Oxford, in Naples, and in Tampere. And what stands in their place instead is a good deal smaller and considerably harder to hold on to. There are correlations between systems, and they accumulate in one direction only. They are produced at a cost, and that cost has apparently been counted out in joules since 2025. That appears to be the entire inventory of what is left standing. All of it, written out on a single page. Think about walking through a house you're selling on the last morning with a printed list in your hand. You go through it room by room in order. The furniture is already out on the drive. The shelves are bare. Only the nails are still left in the walls. Every line on that list gets crossed off with a pen as you confirm that the thing is gone. At the end of it, you are standing alone in an empty hallway, holding one piece of paper. And that paper is likely the only thing left anywhere in the building with anything written on it at all. So, what did the last 2 hours actually take away from you? Was any single part of it something you owned? Nothing you owned. Not one single thing that was yours. What it took away was a picture that you were handed as a child. It was a picture you never once checked against anything at all, in all those years. So look at the thing on your wrist one last time tonight, because it has apparently been honest with you all evening long. It never once claimed to read time. Did it ever once tell you otherwise? It counts things. That is the whole of what it does, and it never pretended otherwise. Something inside that little case repeats over and over without stopping. A small circuit adds all of those repeats up as they come in, and a number changes on the face of the thing, right where you can watch it happen. That is all any of them have ever done. Not since 1967, when the definition was written down, and not for the long while before that either. And you have been doing exactly the same job all along, without ever once calling it that. Your body repeats too, in its own way, cell by cell. Your tissue seems to register whatever happens to it in the world around you, and the count keeps climbing, hour after hour after hour. The difference between the two of you comes down to one thing. That watch on your wrist is not paying for its own ledger. You are paying for yours, every second of every day. Think about the last hour you spent doing nothing much in particular at all. Sitting in a chair by a window somewhere, maybe with the radio on, waiting for somebody to arrive or waiting for something to start. It probably felt to you like time simply passing by while you sat there in the chair. A stretch of nothing much in particular, quietly used up, while you were not paying any attention to it. But was that hour nothing at all? It was not nothing. 20 joules a second went out of you across that whole hour, without a single pause anywhere in it, buying the construction of every moment of that hour. So who is doing the spending in all of this, and who is the one being spent? There is no clock hanging somewhere above the world, running the whole arrangement from outside of it. There is no current running anywhere, carrying anybody forward through anything. What there possibly is instead is a universe full of correlations, and nothing else. And there are certain places inside that universe where somebody has to pay in order to hold a present together. The universe does not spend time, you do, and you are the only one holding the receipt.